Ryan Riley. I'm the team lead for the University of Colorado's of Boulder's Marble team. We were a systems track funded team that have now decided to participate in the virtual competition. The biggest things we've learned from participating in tunnel and urban that we can bring forward in the cave is that our multi-agent capabilities are really nice. Our ability to communicate those artifacts and report those back without having to come all the way back is good. We've also had some lessons learned of what doesn't work well. Some of the things that are struggles are things like localization, particularly in small corridors, and also actually navigating over rough terrain, which is, I think, the biggest challenge in the cave environment for us. We have a very common framework for both our air and ground vehicles. They have very similar missions, very similar hardware. But what we really like to take advantage of is the multi-agent capability and the coordination between them. We developed a really nice differential map system for sharing our maps so that we can efficiently communicate those and operate over that and do implicit coordination. And then we also do an auction-based strategy for explicit coordination to deconflict our goal points. Our initial goals for our robots are to go find artifacts, and which is kind of the name of the game in this. But really, we use a frontier-based exploration approach, planning over an octomap, and we find open area that hasn't been seen and kind of go to the biggest open areas and try to get as deep into the environment as we can. And as we go along, we look for artifacts. What we do is send one robot out first to kind of get the first area opened up, find other frontiers, and then succeeding robots will go through and then fill in all the gaps behind that and also go off in the branching areas. Once we detect an artifact, we immediately switch into a report mode, which means communicate with the base station. If you can't communicate with the base station, then go into a return to home mode. We also drop breadcrumbs throughout, which was a capability we had in systems. And it was nice that in this version of the virtual event, they've added the breadcrumbs. So we're able to still do our extended communications that we'd already were doing in systems track. With verticality challenges, with the ground robots, obviously they can't go straight up, but our robots are able to navigate decent inclines, 20, 30, 40 degrees maybe, and so it's just a matter of just climbing up those. With the air vehicles, obviously they have a more capability, and that's what we really gear our air vehicles to doing, is to find those kind of vertical shafts, vertical areas, and go up those so they can explore those areas that maybe the ground vehicle can't get to. So for dynamic obstacles, we use an octomap-based system for our planning. And so by the nature of that, it will clear itself out if obstacles change as other robots go through. University of Colorado is super excited to be part of the virtual competition now. As I've said before, we haven't got to showcase our capability as much as we think we can, and we think that the virtual is a chance to showcase ourselves really well.